Question 1. Simplify root 5 plus 2 multiplied by root 5 minus 2. Root 5 plus 2 multiplied by root 5 minus 2. Right, in order to do this, I'm going to do 4 bits of multiplication. I'm first of all going to multiply root 5 by root 5. Then I'm going to multiply root 5 by 2. We'll multiply minus 2 by root 5. And finally, multiply minus 2 by plus 2. Root 5 times root 5 is 5. Root 5 times plus 2 is plus 2 root 5. Now minus 2 times root 5 is minus 2 root 5. And finally, minus 2 times plus 2 is minus 4. Now here we see that the plus 2 root 5 and the minus 2 root 5 cancel out. And we're left with 5 minus 4 to give a final answer of 1. An alternative method to solve this is to realize that a plus b multiplied by a minus b is actually the factorization of the difference of two squares. So it's equal to a squared minus b squared. So interpreting that in the problem above, we can say that root 5 plus 2 times root 5 minus 2 is equal to root 5 squared minus 2 squared. Root 5 squared is 5, 2 squared is 4, and of course we get the same answer, 1. Part B of the question. The square root of 8 plus the square root of 18. And we want to get that in the form n root 2, where n is an integer. In this kind of question, we're looking for perfect squares as factors of the numbers under the square root signs. So if we look at 8, that contains a perfect square as a factor. We can write it as the square root of 4 times 2. Likewise with the next one, 9 is a factor of 18. 9 is a perfect square. We can write that as the square root of 9 times 2. Now we're using the principle that the square root of a times b is equal to the square root of a times the square root of b. And so we can say the square root of 4 times 2 is the square root of 4, which is 2, times root 2, because we can't simplify that part of it, plus the square root of 9 is 3, and we've still got root 2. 2 root 2 plus 3 root 2 is 5 root 2. And that provides the answer to the question.